That's a difference. Because the Jeffersons were the neighbors.
Yep.
Yep.
All right. So this is where we left off last week. We talked about these guys and how when we look at them, we have to figure out which one's coming and going to end up being a strong and which one's going to be weak. And it's the weak that we want to focus on. The strong is here. So we're going to focus on this aluminum. Our aluminum then is going to react with water. It's going to then grab which part of the water? This is a positive, so what's it going to grab? The OH, right. And what's it going to leave behind? H plus, right. So this is what kind of salt? Acidic or basic? Acidic salt, right. And they gave us the Ka, which was nice. Anytime you have H's here, you need to use Ka. Anytime you have OH's, you're going to use Kb.
How do you figure out which one's like the weak part?
So do you have your strong acids and bases memorized? Okay. HCl is a strong acid. If it's not one of the strong acids or strong bases, it's weak. You should know what they are by now. All right. So this guy's going to start out. I'm going to have 0.01 molar here. We're going to subtract X and we're going to make X. This X I can do what to? Ignore. But I need to document it. And then I can take my Ka value. I can do my X squared. I'm multiplying these two X's together, divided by 0.01. All right. So then I multiply by 0.01 and then take the square root, and that gives me 3.7 times 10 to the minus 4. That's molar H plus. And if I take the negative log of that, that is what I get. Yay, nay.
Yeah.
So do we not need to balance the equation?
I'm not sure what I'm doing. I don't think it really matters because this one, you're going to end up with one of these. Okay. So yeah, I don't worry about that right now. Okay. Titrations. I believe this is the next thing in your book, yes?
Yeah, I might. Are we gonna be sad after that?
I don't think so.
Oh.
Huh?
I'm also very sad tomorrow, maybe.
Why?
Because like they will show our vlog in front of our classmates.
What?
Her vlog. Yeah, our vlog. They will show our vlog in front of our
She has to show her vlog.
Oh, you have to do a presentation?
No, I didn't do the presentation, but they will watch our vlog.
They just
from
watch,
our other classmates.
Oh, so it's boring?
No, she's gotta show.
Just
She's
very
gotta show her video.
Oh.
Yeah.
Oh, okay. You'll be fine. They'll enjoy it. All right, here we go. Titration. So you guys have done titrations. The nice thing about the titrations that we're doing for this is that if you overshoot the titration, you can go back and add more acid in and then get it back. Well, with that potassium permanganate, if you screwed it up, you were done. There was no, it was not forgiving.
Why does it work that?
Because we were starting off with that sample with the iron in it, and you started out with so many grams of it, and then you had to mix it and everything. this you're just gonna, like, if you overshoot it, you just go back and add more acid in and then titrate in more base. And yep. So this is a little more forgiving. But when we do these titrations, you have your you have the material in here, which in this case they've got a base in there and then they've got an acid. And typically the thing that's in this in here, a lot of times you don't know the molarity of it, but you know the molarity of your base in this, and what's in here. And then you titrate in until you get some sort of color change. So for you guys, it was like it turned purple with the last one, okay? And you have to pick, and we'll talk about how to pick that. You have to pick the right indicator for whatever reaction you're going for. And we'll talk about how we do that, because there's sometimes they'll give you a table and they'll say which indicator would you use to determine you know, the endpoint. Okay, so the equivalence point is where your moles of OH and your moles of H plus, the molarity of those, when those things equal each other, that are not molarity, but moles of them. I guess I should say moles of them. So the moles of this equal the moles of your H plus. Okay. So that's a much better way of saying it. I'm sorry about my previous blunder. All right. So when a weak acid or base is titrated with a strong base or acid, the strong one's going to win. And what that means is if you have a strong acid and you're titrating that with a weak base, your pH is going to be less than 7.
By a little bit or by significant?
It depends.
Depends on the
how weak this guy is. And yeah, it'll depend on concentrations too.
So how do you know, like, and you said the strength is determined by electric activity?
Yeah, a lot of times, yeah. But that's why you just memorize these and you know which ones are strong and which ones are weak. But you know, if you've got a strong acid and a weak base, you're going to end up with a equivalence point less than 7.
Yeah.
If you have a weak acid with a strong base, your equivalence point is going to be greater than 7. The strong wins. If you have a weak acid, or I'm sorry, a strong acid and a strong base,
7.
your equivalence point will equal 7.
Fun.
So typically you'll use an indicator that will change. So you'll figure out what this is going to be, okay, where that endpoint should be. And you pick an indicator that's going to change in that range. So if your pH, like if your equivalence point is 4.2, you're going to pick an indicator that typically will change color in that range. You're not going to pick an indicator that changes between 7 and 8. Does that make sense? For me?
Yep.
Oh, thank you. I have to pick which one I want. Thank you. Oh, it doesn't say who it's from. Well, thank you, my secret admirer. Whomever you might be. Miss Nichols sent me one today, and then I had another chemistry kid, the best chem teacher. That's nice. Say who it is.
Mr. Masterson sent me a lot of
You liar.
No, I have it. You want to see it? No, I got it during his class.
Did you give everyone one?
Yeah.
I knew it. I didn't get one.
Did Miss Kinder send you one of these? You should probably send her one to thank her for all the snacks. Happy Valentine's Day. And then he told Joe and Owen to stop talking to each other. He said, Owen, stop talking to Joe in class. Happy Valentine's Day. And then he said, Joe, stop talking to Joe in class.
That was amazing.
And then I think he said, Jake, stop talking to Owen and Joe in class. I'm popping off the dick. 4 love bombs today, guys. A lot of love.
Zip it. I literally turned mine in for an hour.
3 of them are from Caitlin, okay? 1 of them from his class.
Okay, I'm moving on.
Oh, sounds good.
So like I said, we pick an indicator that's going to change in the correct span. And typically they will have you standardize a solution to make sure that that solution is a certain pH. So that's called a standardized solution. I oftentimes order it in. Honestly, I order it in from the company to make sure that it's the right pH.
Really? You didn't tell them
The
that
right
you-
molarity. No, I just order it in and tell you guys what the thing is, calculate it and figure it out. Because,
Really?
yeah.
That's funny. So you make sure that you use our book to figure out.
No, I buy it from the company, like already standardized.
Oh. Got it. That's fun.
Yeah, makes life a little easier. Okay, so the solution in the burette is called the titrant, and the solution in the flask is called the analyte because you're analyzing it. Okay. Normally, the approximate concentration of the analyte is known. That's the stuff in the flask, which allows the titrant of a similar concentration to be prepared. If the titrant is too concentrated, then only a few drops are required to hit that equivalence point. And then if it's too dilute, you run through the whole burette, which if you were in Honors Chem last year.
Well, this year we got that AP lab and we're gone.
Oh, yeah. Yeah, I screwed that one up too, didn't I?
Demanganate that. Because it was like 10 to the -2 off or whatever.
Oh, I have my moments, you guys. All right. So that transition point, valve of the burette's closed. You know what that equivalence point is. Typically, you repeat your titrations a couple times to make sure that you didn't goof anything. And those that are really good at titrations can get it.
Ellie and us last year. Ellie
We
and me
were
last
so
year.
good.
When we got
Yeah.
it perfect.
Okay.
We were the best at that.
We were
We
very
killed it. Just saying. Why is my finger bleeding? For why?
All right, here they're standardizing this solution. In other words, they're trying to figure out what the concentration of the NaOH is. They're starting, they have 28.15 mils. Okay, and they're going to use that. They neutralize this KHP, and they want us to calculate the concentration in here. All right. So we're going to figure out what our moles are of the KHP.
M1, D1. Right?
No. No, molarity equals moles over liters. So if I know my liters and I know my molarity, how do I find my moles? Right, molarity times volume, or liters, is going to give me my moles. But remember, I need to put this into liters. Good?
Well, can you, after this, find another mole ready to do?
What?
Are we going to do a table after this? With the moles?
There's no ice table for this one, no. Okay, so we've got this guy. We're going to figure out the moles here, which we multiply that 0.025 times this guy. That equals 0.00268 moles.
You do M1, V1, V1, V2, and solve for most for OH.
Yeah, maybe you can. I guess I just didn't think of it that way. So then you're going to divide this by 0.02815, which is my liters of an AOH. And then that's going to equal 0.0952 molar NaOH.
Because the moles are the same for
Yep. Okay. So majority of your titrations you're expected to perform will determine either the concentration, the volume that you need. Sometimes you'll do molar mass, and sometimes you'll do percent ionization. No matter what it is, the total number of moles of H plus will equal the number of moles of OH minus at that equivalence point. That's why we could take up here, we could say, oh, we've got this many moles of this guy. That's going to equal the moles of this because that was where we were neutralized. So we know the moles of one equals the moles of the other there.
But there might be different, like, volumetric amounts, which makes
Oh, yeah.
pH
Yeah.
go to.
Yeah.
God.
All right. So here we have a 25. So let's see here. First step in the calculation normally involves figuring out the number of moles. Second step, then you're going to do a mole ratio into the balanced equation to determine the moles of the second reactant. And then the third, you're going to use the moles calculated up above and typically the volume to be able to figure out what the molarity is of the other part. Okay. So here I have a strong acid and I have a strong base. So I know my equivalence point is going to be where?
It's going to be strong acid, strong base, and 7.
7. Okay. Not that that matters much, but it's just a good thing to kind of in your head get practiced at. All right. So here I'm going to figure out my moles of H2SO4 and I'm going to figure out my moles of NaOH. Well, no, I'm going to figure out my moles of this first, I guess. So figure out your moles of this. Go. So this is going to be 0.025 liters. I'm going to multiply that by, wait a minute.
0.0462.
Yeah. No. No, I need to do that to this. Hold on.
Yeah.
So 0.04623 times 0.203 is going to give me my moles of OH minus. Okay. So that's going to be 0.00938. Okay. And that was the equivalence point. So I'm going to divide those moles by this many liters, because that's also the moles of H plus, right? Because it's at the equivalence point. That's what it means. The moles of this equal the moles of that. So then multiply that out.
We can get 0.3752 mole.
Libby, what class are you guys doing sig figs in?
Regular chem.
Are you really strict on them? Or are you...
I try. I'm just darn happy when they do their homework.
Well, you don't have to worry about us. I usually do mine, around 5th hour or maybe lunch.
Oh,
Hey, if I do it the day of, it's fresh in my brain.
I think I might have screwed this
Oh.
up, guys.
Come on, listen. No, that's right. That's what I did. 0.375 to the molar. I did 0.0093 divided by 0.325. And then I have the molar.
Yeah, NaOH. Yeah, this is right.
Yes,
Yeah, I'm
you're
okay
right.
with that. Yeah.
Could be, you're right. Could be.
Oh my gosh, did you just say this time? You asshole.
Ellie, be nice.
Ellie, be nice.
He was being rude about your chemistry skills.
Oh, I suck sometimes, honey.
No,
No.
you don't.
Yes, I
There's a reason I ask Libby questions all the time. I don't necessarily know what I'm
don't.
doing.
I cannot believe that he would say these horrible.
I wasn't saying anything.
do. All right, now I have this guy right here, right? I have 2 moles of H plus for every 1 mole of H2SO4.
Whoa, 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 whoa. Where are you getting these numbers from?
H2.
So you have 2 moles. So you have to multiply whatever or divide whatever I get. Right?
For every one of these, I've got 2 of these guys.
Gosh.
Do you see that? 2 and 2? You see where the 2's came from?
Yup.
Right?
So it's 187.1876 mole.
Yep. So then, once I get that done, that's going to give me my moles. And then I'm going to divide that by my liters, which is 0.025.
And you could technically go add on to like just that table and just do it all at once. So multiply 0.025 by 2. And then
Yeah, so
So, anyone have any plans after school today?
Basketball practice.
Practice.
Guys, I don't start practice till March 7th.
What about you, Matthew? Do you have any plans?
Actually, yes, I do.
No one asked.
No, you don't. You're lying.
What do you think?
What is your plan?
Oh, Valentine's Day.
That is so cool.
I'm dating my dog.
Oh,
all right, questions.
nope, Libby, we're good. How long do these notes go for? Holy cow.
It's a lot.
A lifetime.
Libby, where do they end?
Well, if you'll notice that I gave us like 3 days on titrations.
Oh, you did.
Wow.
So we don't have any homework tonight?
Like it says, to be determined. I don't know where we're going to leave off today. So
Libby,
that's why I really don't know.
I'm gonna cry.
Shut up.
This is a TV.
You know what?
Fourth hour didn't have anything.
Yes, we did, because we didn't get as far as you guys.
Where actually, I'm kind of confused where we got the 1 mole of H2SO4.
Here?
Yeah.
This is just a ratio. Yeah. For every one of these, we have 2 of these. It's like for every motorcycle, you have 2 tires.
Guys, Libby has a little puppy thing up there. That's so cute.
For every one of these, you have 2
And then
hydrogens.
And like, the sentence above it says
Which one?
H2SO4.
Right there. It's
Yeah,
all
right
the
here.
next to sync. It's a little puppy calendar.
Oh my gosh.
My grandma buys my mom one.
Can you give me? Can someone buy
My
me-
son buys me that every year.
That's so cute. My mom buys my dad a husky calendar every year. Like my dad had a husky, but no longer does have a husky. But did.
Aww.
All right.
Really cute.
So calculating solution volume. and this is where I flubbed up in your hour, Ellie. And
That's all right.
then I recovered during lunch, but it took me a few minutes. All right. If you're asked to calculate a solution volume from titration data, you're probably given the concentrations of both the acid and base. If you aren't given the concentrations, a lot of times you can figure it out by using stoichiometry or by using the pH.
So you take the negative
So
one.
here, yep, I can take 10 to the negative, and it's going to be negative 0.5
Why 13, not 13? Oh,
because I want to figure out OH, right?
it's easy to that mental math, like on us, like that.
Well, 14 minus 13.5
I
is
know.
not a stretch.
Yeah, but here's the thing though. I didn't notice that. You did. That's what separates me as the student and you as the teacher.
So I figured you guys could probably subtract this from 14 without a calculator.
Well, sometimes do you ever like do simple multiplication in your head and then put it in the calculator just to make sure?
Yes.
Like I'll do like
I
4
doubt
times
myself all the
5,
time.
or, like 3 times 5 to be like, okay, I know
Okay.
I know what the answer is.
So when we do this, we are going to figure out that our yeah. So if I take
Can you do M1 V1 because M2 V2 in this one?
What is your obsession?
Because it's a good equation that we never get to use.
You are an idiot.
okay, I see what I did. Okay.
You know what? Allie?
My name is Ellie, not Allie.
What? Ellie.
At least you say the right name, you idiot.
Wait. Okay. I'm gonna try something here. Now correct me if I'm wrong, but I'm gonna try something.
You're wrong.
No one asked you or you.
I'm just being honest.
What? You don't have to make it. Words hurt sometimes. You know?
No, they don't. You're fine.
Okay. So I
Whatever.
am going to take this guy right here.
Yeah.
Oh, shoot.
And multiply it by
Hold on.
0.025.
Yes.
Yes.
And I'm going to multiply it by 0.025. That's going to give me
Your
my moles
of HCl.
of H plus. Or, yeah, I just like to think H plus. It just gets rid of that extra bit that I don't need. All right. So that is 0.01058.
And can't you do 0.010 or 0.0106? Do you want us to use? Do you want us to use that many sig figs?
I kept that many because they had like a lot up here. So,
Yeah.
okay. All right. So that's my moles of H plus, right? Now, I know that I have a molarity of this guy. So 10 to the negative 0.5 gives me a molarity of 0.316 molar OH minus. Okay. Now, what is molarity? Moles over liters, right?
I'm seeing where you're getting at, Miss Lippy. When 0.058 divided by 0.316 should give you liters,
Matthew, I'm sick and tired of you talking.
which you can convert to milliliters.
Did they ask what? They didn't ask for milliliters, so I can leave it as liters.
Yeah, but everything else is in milliliters, so it kind of makes me more happy. Hey, rock on, Lippy.
So you want it to be 33.4 milliliters?
Yeah, because everything else is in milliliters.
That's fine. The problem with that is, okay, and I'm going to tell you straight up, you they don't ask you for it in milliliters and you calculate it right in liters,
And write it.
but you do this and you calculate it wrong, they're going to mark it wrong.
Well, it's big. I know, but I won't do that.
That's fine. I'm just saying, the more you try to show off to them that you're smart, the more chances you are of screwing
But
something
what
up.
if you are smart and then you get it wrong?
Why have better chance of getting a better score than that?
No,
This is
that's not
why-
at all what she just said. Zero.
I'm just saying, be careful. They don't care how smart you are, just if you got the right answer or not.
So you're telling me I can cheat off of someone to get the right answer? And then...
You cannot cheat. No, cheaters are losers. Winners never cheat and cheaters never win.
I'm just gonna keep my mouth shut. I'm just gonna keep my mouth shut.
Your mama and daddy would agree with me.
Yeah, that's true.
Mm-hmm.
My dad loves catching people that cheat. They'll like just stand there and watch them, and then they'll like look up and I'll be like, "Hey."
I don't, because it's too much paperwork and they don't get punished now anyway. So why
My dad
bother?
literally just like.
That's
stand-
why in regular Kim I run off 2 different versions of the test. I do it on 2 different sheets of paper,
Do you
colors,
alternate?
so that
Do
they
you,
know.
like, alternate?
Oh yeah.
Well, because sometimes the kids like try to use their phone, and my dad will just stand there and watch them do it, and they'll eventually look up and I'll be like, "Hey."
Yeah.
And then I'll like take the test.
Wait, what do you do with the? You run off 2 versions of it. One's colored and one's not.
Well, I have one that's like here, one's yellow and one's blue, and I hand them out every other one,
So they can't
and
cheat.
then they can't cheat because they're 2 different versions.
I
And if they do cheat, they're gonna fail because they're gonna get the wrong
And you'll
answers
know they're
from somebody
cheating 'cause
anyway.
they'll have the answers.
Yeah, but I don't want them to cheat because it's more paperwork and calling home.
Do you have to,
and all
do you
that
have to
stuff.
do you have to fill out academic exams?
And then on top of that, they let them redo the thing for full credit, so they're not
Exactly.
getting punished. Yes.
This is outrageous.
Rigged.
And then all they get is a closed lunch detention. That's all they get. It's like, it's not worth my time.
It's not worth my time.
Mm-mm. And if you go to college and cheat, they'll kick you out. So, and not give you your tuition back.
Dang, that's so.
Mm-hmm. Telling you.
No.
All right.
Allowed.
Give that everyone.
Well, we're a little ahead of the other hour, so I'm
Do
going to
that.
stop
We'll do that
there.
forever you
Yeah,
want.
you guys are extreme.